Hello, my name is Mr. Asprey and this is number 60 in my IGCSE exam question series. This is the last one. This is vectors. If you have watched every video so far, then you're an absolute legend, and even more so if you've liked every video, then you're an absolute hero. Or if you've just joined for this particular video, then you're in for an absolute treat, because I think this is the hardest topic in the whole IGCSE. So, without further ado, let's get into these questions, all of which are tricky. Okay, here we go. So all these questions are the back end of the paper. We're looking at questions, 22 and sort of onwards. Right, we need to get from E to X, and we know that A to B, I'm going to use highlighters to help us out here. A to B going in that direction is little a, and B to C going in this direction is B. Okay, so how do we get there? Well, we can, because this is a regular hexagon, we can draw on lines like this, of all which will be the same length, like that, and we can go, let's go first across, so that's A, and then let's go negative B, and then let's go A again, and then let's go negative B again, and then let's go A, and we get there. So simplified, that's 3A minus 2B. It doesn't matter which way you go, you're always going to get the same answer. That's the beauty of vectors. Okay, tricky question straight away, because we have no real information here in terms of a diagram. So a good idea would be to draw our diagram ourselves. A, B, C, and D. That's great, because DC is 3 lots of AB. So if this is X along the top, this is 3X along the bottom, like that. And we are told that D to A, we know, going in this direction, and D to B, we also know, going in this direction. So it says find the magnitude of B to C. Okay. Well, let's first work out B to A. That would be quite useful. So B to A is equal to, we'll go backwards through D to B, so minus D to B, and then we'll go forwards through D to A, so add D to A. Okay, what's that as column? So minus 1, that's 1, and then plus minus 2 is minus 1. And then we've got minus 7 plus 3 is minus 4. Okay, great. So now, if I get rid of these highlighted parts, now what we have is we have B to A, so that's going to take me from there to there. I could then go down AD, because I know DA, and then I could go across DC, because I know it's 3 times AB. So if I want to go from B to C, then I can do B to A plus A to D plus D to C. So B to A we know already, we just worked that one out. A to D is the negative of D to A, so that will be 2 minus 3. And then D to C is 3 times A to B, which is 3 times the negative of b to a. So it's 3 times 1, 4. Okay, this gives us, reading along, minus 1 plus 2 plus 3 is 4. And minus 4 minus 3 is minus 7. And then plus 12 is plus 5. And we're not quite done yet because it's asked for the magnitude of b to c. And the magnitude we write like this. And we calculate it by Pythagoras' theorem by squaring each component and then taking the square root of it. So I would do the square root of 4 squared plus 5 squared. And that's root 41, and it's asking us for the exact value, so we are good. Okay, next question. We have O to A is 3A, O to B is 6b, and A to C is 4b, all given on the diagram. N is the point on OC such that ANB is a straight line. Okay, so that is the point there, N. And it says find ON as a simplified expression of A and B. Right, so what we're going to have to do is we're going to have to come at it from 2 angles. So first off, I am going to look at O to C, so going along that line like that. And that will be 3A plus 4B. Okay, because we go 3A plus 4B. And then what we can say is that if I wanted to work out O to N, then it would be a multiple of O to C. It will be a fraction of it. It might be half, it might be 3/4, we're not sure yet. But what we'll say is that O to N is equal to lambda of O to C, which is 3A plus 4B. You could use any letter there. I've just chosen lambda. I'm not sure why. Okay, then what you need to do is come at it from a different angle. So I'm going to look at this line here because we're told that that is a straight line, so we're going to have to use that somehow. So my first step is to work out A to B. And that will be minus 3A plus 6B. Okay, and now A to N is some fraction of that blue line. It's not going to be the same fraction, so we're going to give it a different letter. I'm going to call it mu. Like this. And then what I could do is I could create an O to N using A to N. So I could go up to A and then across there, and that's going to get me from O to N. So that will be 3A plus AN, which we've just worked out is mu lots of minus 3A plus 6B. And now we have 2 expressions for ON, which is what we need. And what we'll do next is equate them. So we'll have lambda 3A plus 4B is the same as 3A plus mu minus 3A plus 6B. And then we'll need to compare coefficients, because in order for these two to be equal, the A's on one side must be the same and the B's on one side must be the same. So let's first look at how many A's we have on the left side. We have 3 lambda, lots of A, and we have 4 4 lambda, lots of B. Okay, and let's look at this side. Well, we have 3a, and we've also got minus 3 mu a. So in total, we have 3 minus 3 mu lots of a. And in terms of the b, we're just going to have mu times 6b. So this is going to give me 6 mu b. Okay, great. Now what we could do is we can compare coefficients, because like I said before, the a's and the b's, they must be the same on each side. So this tells me that 4 lambda must equal 6 mu. And then also looking at the a's, these must be the same on both sides. So 3 lambda must equal 3 minus 3 mu. Okay, great. Now what we can do is solve simultaneously. So I can multiply this one by 2 to get this, and then I can write this one below it, and I can add them together, and I get 10 lambda is equal to 6. So lambda is equal to 6 over 10, or 3/5. And now let's look at this. This is an expression for ON. So ON is equal to lambda, which is 3 over 5, lots of 3a plus 4b. And that's it, we're done. We've worked out an expression for ON in terms of a and b. Perfect. Right, here we go. Let's do another one. O to A is A, that's C. We've also got A to B is 2C. So this is, so this is 1.5 C, and this part here is 0.5 C because of this 3-to-1 ratio. 3-to-1, that works, and it has to be 2C in total. It says use a vector method to find A to Q Q to C, and it also says that OQP is a straight line, so that goes through like that. Okay, we're going to do the same thing as before. We're going to find an expression first for O to P along that line. So O to P is A plus 1.5C. Just checking these do go in that direction. Yes, they do. So that is A plus 1.5C. So O to Q is some fraction of that amount. Again, I'll just call it lambda. It could be a half, looks about a half, but it's not to scale, so who knows. And then we need to go about it a different way. So now let's look at A down to C. Let's work out A to C. So we could go minus A plus C. So minus A plus C. And then A to Q will be some fraction of that vector. We'll call it mu minus A plus C. And now with that, I can get another expression for O to Q. Because what I could do now is I could go up to A, and then I can use AQ to get back to Q. So going up to A will be little a, and then I need to add on mu minus A plus C. Okay, great. And now what have we got? We've got two expressions for O to Q. So we can equate them. So this tells me that lambda A plus 1.5C is equal to A plus mu minus A plus C. And then we can look at the A's first, and we've got lambda A on that side. and on this side we're going to have 1 and a minus mu. So we'll have 1 minus mu lots of A. And then we can look at the B's. Over here we're going to have 1.5 lambda C, sorry, not B, C. And when we expand this one, we're just going to get mu C. Okay, great. Let's look at the C's first. This tells me that 1.5 lambda is going to equal mu. And then let's look at the A's next, and that tells me that lambda is going to equal 1 minus mu. So I can just write one of them below the other, and then we can add them together. And this will give me 2.5 lambda is equal to 1. So lambda is equal to 1 over 2.5, which is 0.4. Okay, great. And now what are we actually after? We are after the ratio of AQ to QC. Well, great, we already worked out that AQ was some ratio of, or some fraction should I say, of AC. So we just need to work out what mu is actually. We've got lambda, so let's just find out what mu is. Well, mu, by going back into this equation, mu is equal to 1.5 times by lambda. So times that by 1.5, and we get 3 over 5, or 0.6, or 3 over 5 might be better actually, because mu was the fraction of A to Q, so that's 3 out of 5, which means this part must be 2 out of 5, which means the ratio must be 3 to 2. Done. Wallop. Bosh. Right, tricky question alert. We have a triangle OAB, and it says that C is the midpoint. And it says that if I draw a line AB and I put this here and call it D, if this is 3/4, that would be 1/4. So it's in the ratio of 3 to 1. So 3 to 1, 3/4 to 1/4. And this one would be a half as well, because it's the midpoint. And then this is tricky. It says that OB is equal to 2 times BE, which means OB is bigger, because it's equal to 2 times something else. So in order for me to get to E, I just have to go half the way along. So if this is B, then this is a half B in here. Because if I were to double that, so times it by 2, it would equal this, like it says here. And then it says that this is a straight line. Yeah, it looks pretty straight to me, pretty happy with that. And let's just fill it in that these are A's. And then the only part of our diagram which is not filled in is my A to B. So that's where I'm going to start, A to B. So to get from A to B, I have to go through minus that line, because that's going in the wrong direction, because these are all pointing that way. So that's minus A. And then I would need to go along here, which would be plus B. Okay, great. Let's see if I can get rid of that highlighting. Okay, so now everything's labelled. This is minus A plus B, and this is 1/4 of minus A plus B. And in order for me to show that 3 points are on a straight line, I have to show that all 3 points are moving in the same direction. Actually, that's not quite correct what I said there. I have to show that the vector of C to D is moving in the same direction as the vector of D to E. Or you could also say that the vector of C to E. So you need to work out two of these and show that they are parallel. It doesn't matter which, any two is absolutely fine. So let's do it. So let's first do C to D is up a half A, and then this is the direction A to B, so it is in this direction. So we're adding on a half A and 3/4 minus A plus B. Okay, so we can simplify that. A half A plus negative 3/4 A is 1/4 A. Sorry, negative 1/4 A. And B, we have 3/4 B. And then I can work out D to E next. That would be 1/4 of minus A plus B. So 1/4 of minus A plus B. And then add on a half B. I can expand and simplify. I'm going to get minus 1/4 A, and I'm going to get 3/4 B. And look, that's perfect. I mean, they're definitely parallel. They're exactly the same. And that will be enough. You're done. But you could also work out C to E would also be a valid way of doing this question. And just to show you what that would look like, minus a half A going downwards, and then plus 3/2B, like that. And then finally, just to really show how that these are parallel, we could take out a factor of 1/4 here, and that will give me minus A plus 3B. And we could take out 1/4 here, which will give me minus A plus 3B. And we could take out a half here, which will give me minus A again plus 3B. So because these are all parallel, it means that a CDE is on a straight line. And we're done. Finished! All 60 topics completed. If you've watched all 60 of my videos, you know, you're pretty much on for a grade 9. And thank you very much for watching them. I really hope that they were useful. And if they were, please do like the video, subscribe, and share with your friends as well. That would be greatly appreciated. Okay, that's it. Bye for now, and I will see you next year for A-level maths. Let's do it.